Good afternoon, everyone. Welcome to our new tutorial video. Today we're going to tackle about Descartes' rule of sign. To, to define what is or to know what is the use of Descartes' rule of sign, René Descartes established a rule in eliminating candidates for a lengthy list of possible rational zeros. A while ago, or on our previous video about rational zeros theorem, we are we 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 tackle on how to get the possible values of x or the possible rational zeros. And because there are many possible values of zeros, the Descartes rule of sign tends to help us identify how many positive numbers or how many positive or negative numbers does a polynomial function have as its zeros. Now, to describe these rules, we need the concept of variations in sign. A variations in sign occurs whenever adjacent coefficients have the opposite signs. So let me illustrate to you in this example. Now, in doing this, a polynomial function with a real coefficient must be written in descending powers of x or in standard forms, and omitting the powers with equal to 0. So let's consider this. Now, all we need to do is to check if it is in standard form. And as I can see, this is in standard form because it is 5, 4, 2, and x raised to 0. Next is we check the sign of the leading coefficient. The sign of the leading coefficient is positive. So from positive, let's check if there is a variation on the sign of the next term. So from positive, it becomes negative. So therefore, there is one variation. Now from negative, it becomes positive. Now there is another variation on that. And positive and it's become positive. So there's no variation. So therefore, in this example shows that two variations of sign in P of x. So that's how the variations of sign work in this example. Now let's define the Descartes rules of sign. It's written in the rules that the number of positive real zeros, okay? Now we're talking on the number of the positive real zeros of a polynomial x is equal to the number of variation of sign of that polynomial or less than an even number. So meaning, if we count the variation of phi of x, and the number of that variation are the numbers of a real positive zeros or that number less than an even number. So on the other hand, the number of negative real zeros of a polynomial x is equal to the number of variation in signs in p of negative x, or it is less than by even number. So all we need to do is substitute negative x to the values of x, and let's evaluate that, and let's count the variation of signs, and that will be the value of r, that would be the value of, or that would be the number of negative real zeros of that polynomial. Again, if it is greater than 2, so the value of negative should be 2 and 2 minus 2, which is 0. Now let's put that in an example. Use the Descartes rule of sign to determine the possible number of positive and negative real zero of this polynomial. Again, let's check if this polynomial is arranged in standard form. And as I can see, it is in standard form because it is 3, 2, and x raised to 1, and x raised to 0. So we're good on that. Next is we count the variation of sign to solve for the number of positive numbers. So we have 1, from positive to negative. Then negative to negative, there's no variation. From negative to positive, and that is 2. So according to the rule, this polynomial has two positive real roots or 0. Okay. Why 2 or 0? Because that's in the rule. Why minus even number? Because maybe there's an irrational imaginary 0, or because it is imaginary 0, so all imaginary 0 are conjugated, meaning they come in pair. So if the number of positive numbers are 2 and 0. Now if we going to compute for the number of negative real zeros, we just substitute negative x to x. And let's somehow evaluate it. Negative x cubed is negative x cubed. Negative x squared is positive x times negative 3, that would be negative 3x squared. Negative x times negative 13, that is positive x plus 15. Now after we evaluate, let's try to count the number of variation. From negative to negative, so there's no variation. From negative to positive, there is 1. Then from positive to negative, there is none. So if the value of our positive a while ago is 2 or 0, then the value of our negative is 1. And since 1 doesn't have, if we cannot less 1 into an even number. So the value of that is 1 only. So there's a possibility that there are two positive numbers or zero positive numbers. And there are one negative number for sure. Now let's try to work on the Descartes rule of sign. The sign table. Let's look at first the polynomial. If it is in third degree, therefore there are three possible values of x. Again, the degree of the polynomial is 3 or cubic. Therefore, the values of x should be 3. So again, we know that the possible values of the positive values of polynomial is 2. Therefore, we have one negative number, and 2 plus 1 is already 3. So therefore, there will be no value imaginary for our imaginary 0. Now, in case, again, it's written on the rule, it is the number of positive or negative 0 should be the number of variation minus even number. So in these two, only two can we minus an even number. So 2 minus 2 is 0. If you cannot subtract 2 or an even number to 1, so you just copy 1. And where does the 2 go? It goes to the imaginary root. Okay? So now, if we're going to add this, we have 3 as example. So these are the tables of sign that is complete. Now example number 2. Now let's use the Descartes rules of sign to determine the possible number of positive and negative real zeros. Let's write it and check if it is in standard form, and it is in standard form. Now to get the number of positive zeros, let's try to count the variation. So from positive to negative, that is 1. From negative to negative, that is none. And from negative to positive, that is 2. And from positive to negative, that is 3. So if we're going to use the sign, we have 3, or 3 minus even number, which is 2. That would be 1. Okay, now let's go to the negative. Let's substitute negative x and let's evaluate it. Now let's count the number of variation. From positive to positive, there is none. Then from positive to negative, that is 1. The negative to negative to negative, that is none. So we have 1 on our um, negative number. Again, let me write it. These are 3 or 1 positive number, and this is 1. Now, assuming that the number of positive zeros are 3, let's write 3 there, and the number of negative is 1. So since it's in the degree of 4, the total of the value of 0 should be equal to 4. So 3 plus 1 is equal to 4. So therefore, we have 0 imaginary roots or 0. Now imagine we have 1 because 3 minus 1 could be a possible number of 0. 3 minus 2. So we have 1. So the number of our negative is also 1. So the two even number that we subtract from here will be go to imaginary. So that is 1, 1, and 2, and that is 4. Now you notice these are the possibilities. So upon studying this, there is sure we are sure that there is one negative values of zero and one positive values of zero because of the table. Okay, so that's for example number two. The answer this is three or one and one. So three, one, zero, and two. Okay, that's all for our Descartes rules of sign. If you want more examples, I'll be happy to create another video about it. And to clarify it, we use this to eliminate other values in our list of possible zeros. That's all for today. Goodbye and thank you.